Coming up right now is the Space Show.
This is your community radio station, 88.3 Southern FM.
Welcome to the Space Show, presented by members of the Space Association of Australia. Hello, I'm Andrew Rennie, and on the panel and mission control way back on Earth is Richard. But let's go now to the Monash University City Campus, end of last year. I had a chat with Patrick Oppel from CUAVA and the School of Physics at the University of Sydney. And we talked about a satellite that was being launched recently. It's called Waratah Seed. Welcome to the Space Show. I believe you've been working on a satellite called Waratah Seed.
Yes, exactly. So we started work on Waratah Seed 4 years ago, and it was launched last year in August and has now been in space for 15 months.
A lot of satellites, small satellites especially, are dead on arrival for various reasons. Your one was not.
No, exactly. We were very lucky. We actually had the first signals from our satellites just 5 hours after launch. So launch was planned to be at 4 a.m. Australian time. So we all got up very early and got together on a Zoom call and watched the launch on the SpaceX live stream. And then a couple hours later, I met my colleague at the university, and we sat next to our ground station and listened in when the satellite first came overhead. And yeah, there it was, and that was very exciting.
Waratah Seed was a sort of a ride-share mission, a bit like catching the bus. What were some of the payloads on board or experiments?
Yeah, so we had payloads from industry partners and universities on board. A total of 9 payloads. A GNSS receiver. That was the first time that that team from UNSW actually got data from a receiver they launched, and they've done that for 10 years before.
And GNS is?
The Global Navigation Satellite System, so GPS. And there was a thermal management payload from the University of Technology, Sydney, that used a novel type of 3D printed heatsink, in which they also injected a phase change material, which prolongs the time you can use your electronics potentially. That was the main result from their test. That was our 2 main payloads, and then we had 7 secondary payloads. 5 of them came from a payload competition that we ran at the very start of the project. These were all sponsored, so they had to the price for the payload space was reduced, and all those 5 payloads came from startups from Sydney. One of them was a space edge computer, so that was for AI in space. There was a payload that was testing mechanical sensors, touch sensors, that could be used on robotic arms in the future in space, because you need some sort of force feedback, how strong you grip things. There was one payload that was testing like biodegradable materials for their use in space, if they the radiation environment or the harsh environment of space has any impact on them. The other 2 were solar panel payloads. Yeah. So one of them came out of the University of Sydney, a spin-out called Europa Power. They're doing perovskite cells. It's a new type of solar cell. They could potentially be deposited on any thin layer of any material in very thin layers, so it's very flexible. They're at the moment not as efficient as the triple junction cells that normal satellites are using, but they can be. There's research going into that to make them as efficient, and they're very cost effective compared to the current cells. And then the other experiment came out of UNSW, a spin out. It's called extraterrestrial power. They're using standard silicon cells, which is the same that we use on terrestrial applications. And then we had 2 more payloads. One is from another startup called Deneb Space. It's a magnetorquer. It's based on a PhD work from a student at UCIT. It is an electropermanent magnetorquer, which is more efficient than conventional ones. And then last but not least, we had an experiment from our own team at CUAVA, which was a electron density and debris instrument. So that measures the plasma environment around the satellite to detect, first of all, like plasma waves, but also what it can detect is if a small particle, sub-millimeter particle, hits our spacecraft, there's going to be a small plume of particles ejected, which would be detectable in the radiation.
With that long list of payloads, it sounds like you had a huge satellite, but
it was only the size of a shoebox. Yeah. So most of the experiments were fairly small. So the standard was the average payload was really just one PCB, 10 by 10 centimeters, and like 2 centimeters high. That's what the measurements that we gave the teams they had to work with, but they all did a great job to fit the experiments inside of those constraints and do some very valuable science and get results for their startups, commercialize their products.
That's why they call it microelectronics.
Yes, the micro is really in there. Yeah.
Okay. Anything else you want to tell us about the satellite?
What else to say? I mean, there's so much more to say that probably could fill hours of this show, depending on the questions and directions you want to ask. Something specifically...
For example, why was the name Waratah Seed chosen? Obviously something to do with New South Wales.
Yes, exactly. So Waratah Seed was New South Wales... It's sponsored by the government of New South Wales. So it was the New South Wales Space Qualification Mission, or Pilot Space Qualification Mission. So the first of its kind, and the most ambitious rideshare project to help the startups that were on board of our satellite to gain the space heritage, because that's really the first thing, or the most important thing you need to be able to sell in the space industry is you need to show that you actually can build stuff that works in space, and then only people will buy it. Otherwise you can say your product is better than anything else, but if you haven't flown it, nobody will buy it. Yeah.
Well, thanks for joining us on the Space Show.
Thanks for having me.
And that was Patrick Oppel from CUAVA at the School of Physics at the University of Sydney. Someone else I spoke to at Monash University here in Melbourne was Xuelieng Bai. He's a satellite engineer with CUAVA at the Sydney University. Here's how our conversation went. Would you like to identify yourself, please?
Yes, so my name is Xuelieng Bai. I work at the ARC Training Center for CubeSat UAV and their applications, namely CUAVA. So we're a research center at the University of Sydney, but the CUAVA Center is a consortium including a few Australian universities, US universities, and Australian companies and government units. We build satellite platforms and UAV platforms to help our partner to carry their payload to air and to space, and do technology demonstration about their design and instruments.
It's some time since we talked about CUAVA on the Space Show, and could you update me on what's happened with CUAVA 1 and CUAVA 2? And I think you're also involved in the Waratah Seed.
Yes, so a lot happened since CUAVA 1. CUAVA 1 was our first 3U CubeSat mission that launched in 2021. CUAVA 1 unfortunately didn't quite work, so we're still doing some research around it, but essentially many of the electronics on CUAVA 1 failed. We didn't get contact, mainly due to the impact of COVID, and a lot of students left us at that moment, so we got a lot of discontinuity on the CUAVA 1. But CUAVA did provide us a lot of experience. So we're building on 2 CubeSat programs after that, namely the CUAVA 2 and the Waratah Seed 1 CubeSat mission. Both these 2 missions are built almost at the same time. One of them is focusing on academic groups. So we're kind of carrying their research payloads and instruments and do technology demonstration. The Waratah Seed 1 is a satellite doing a red share concept. I believe that's the first one in Australia for CubeSat platform. We basically launched with 9 different payloads from different companies, helping the small companies to validate their first product, basically.
So to put it unkindly, CUAVA 1 was dead on arrival.
CUAVA 1 is dead on arrival, yes, unfortunately. But once again, I think the legacy of CUAVA 1 continue to live on CUAVA 2 and Waratah Seed. All the software and the hardware experience we have gained there, that wasn't a waste, I would say.
So we move on to CUAVA 2, and it's in space, and what's happened now?
So both satellites reached orbit fine. We received signals from both satellites on the first pass, thankfully. Since then, we've been doing commissioning on both spacecraft. These 2 spacecraft have the same bus. We deliberately designed the 2 spacecraft similar in many ways. We carry the same payload on similar payloads on both spacecraft to achieve some mission level redundancy, which really paid off at the end. So we successfully actually first detumbled and commissioned the CUAVA 2 spacecraft. But unfortunately, radiation hit us. So one of the SD card on the CUAVA 2 satellite died just 3 weeks after deployment. But we were able to switch to the redundant SD card successfully. That went really well. Quite unfortunately, about a month after that, we got another radiation damage, and this time it damaged the SD card on the payload computer, and stopped us from doing a lot of important science missions. Fortunately, we do have payloads on the main bus on CUAVA 2, so we're still able to do a lot of radiation and space weather studies. Waratah Seed 1, on the other hand, we got really successful. The Waratah Seed 1 actually commissioned a bit later than CUAVA 2, but somehow it dodged the radiation effect, so now nothing really happened to it so far. The onboard computer and the payload computer both worked fine until December 2024. Just 4 months after deployment, we got 2 primary payloads both commissioned and tested. That's already a mission success. By May 2025, we got 8 out of 9 payloads successfully demonstrated in space and received the data and sent back to the companies. Many companies got funding because of that. I think it was a really successful mission. We actually awarded, for that Waratah Seed 1 mission, we actually awarded the AIAA Small-Sat Mission of the Year of 2025. I think that's the first time we ever got this in Australia.
Waratah Seed was a ride-share mission. What does that mean?
Just like Uber. So basically, entering space is expensive. A lot of startup companies, in particular, they couldn't afford the $200,000 launch fee. So what we do is we build a platform that we know that works. Then we share the space with them. They pay a small amount of fee, then got on board of the Waratah Seed and get their payload tested. So that's our sort of principle on the Waratah series missions.
More like catching a bus.
More like catching a bus or catching a Uber.
Where you share with other people.
Correct. I would prefer not as many people as on a bus, but we do carry a lot of payloads on that CubeSat. Yeah.
So moving on, what plans do you have?
So the Center for CUAVA is reaching the end of the operation, unfortunately. We're running out of funding, but I think the majority of us will continue to work at the University of Sydney to different space missions. But we're also pitching for Waratah Seed 2, build on the success of Waratah Seed 1. We're hoping to build a much larger, maybe a 12 or 24U satellite, so carry more payloads and do more serious commercial demonstrations up there. Whereas we're at this stage still try to pitch for fundings and kind of getting interest from companies. We'll see how it goes.
So they say, space is much, much cheaper than the billions of dollars it used to cost, but it still costs a bit of coin.
It depends what you compare with. I mean, the housing price in Sydney is getting crazy. Like you spend $3 or $4 million and get average house basically. But space mission got significantly cheaper since say 10 or 15 years ago. But it's still a very expensive and risky business to be. And because of that, the lower the entry cost is, the easier for the startup company to start and grow. I think that's what we're trying to do, to contribute an affordable platform for the commercial companies to actually demonstrate the value, the commercial value in space, which is not easy, I have to admit, but that's what we're trying to do.
Now, CUAVA 2 and Waratah Seed are both in sun-synchronous orbit. It's a pretty dangerous place to be.
That is correct.
In terms of debris.
That is correct. So unfortunately, fortunately and unfortunately, most of the SpaceX rockets goes up to the sun-synchronous orbit. That's partially driven by the market because it's easier for sun-synchronous orbit. You're basically expecting your satellite pass overhead at the same time in the morning, at the same time at night, roughly the same time, plus or minus an hour. But unfortunately, that's a really crowded orbit. So Starlink itself is putting hundreds of satellites into orbit a year, if not thousands, and the collision risk is increasing. That being said, space is a three-dimensional place, so the collision risk at the moment is not so high. Starlink is trying to maneuver themselves away from the collision. Many companies are trying, like Leo Lab, they're trying different ways to monitor and track the debris. But it's more and more a problem now, especially the spectrum, for example. When you have two satellites get really close together, you have your communication channel jammed. You can't distinguish your signal with the others. So that's become more of a problem today. And the collision problem, as you mentioned, will be a problem in the short future, in the near future.
So would you consider putting small micro thrusters, small thrusters on board so that you can just nudge it slightly so you miss a collision?
Yes, if you do it correctly. Because predicting a debris, the relative motion in between the two objects across different orbits are relatively fast. The time between you detect the debris and you make a maneuver, making a maneuver in space is difficult. So that time window is really short. So you have to rely largely on the ground infrastructure to warn you, make you warnings to warn you that debris is coming, like what the SpaceX is doing at the moment. And it's very difficult to make the satellite smart enough to maneuver itself in space autonomously. That being said, I'm personally involved in a startup company called Dynap Space. We're trying to make the satellite more autonomous, make the satellite a bit smarter. I don't know if we can achieve that in the next 2 or 3 years, but that's definitely our long-term goal.
Well, watch this space. Excuse the pun.
I think space is a very attractive place and a very valuable place for us all. Space is a place that we have to work together. If not, when collision happens, there will be a chain effect and the whole orbit will be filled with debris. I watched an animation called Wall-E many years ago. So I remember seeing that when the rocket kind of penetrates the Earth's atmosphere, there's a huge amount of space junk around it, and there's no place for any satellite at that stage. So hopefully we don't get into that stage ever.
Yes, we just the last couple of weeks on the space show we've been doing a feature on the Kessler syndrome in relation to the Zhenzhou 20 incident.
Right. So I think that's likely to happen in the near future, and we'll have to look into a solution very, very quickly.
Well, thank you for joining us on the Space Show.
Thank you. Thank you. My pleasure.
I was in conversation with Xuelieng Bai, a satellite engineer at CUAVA at Sydney University, and I was speaking with him and Patrick at the Australian Space Research Conference, which was held at Monash University in the city. This is the Space Show.
88.3 Southern FM. The sounds of the Bayside.
Where you're listening to the Space Show. The Karman Project is an effort to set the groundwork for strategic discussions on the future of space cooperation for positive effect. It aims to remind everybody that space is fundamental to the human experience and that achieving true global cooperation can position space as an equalizer for humanity. Well, this is a promotional feature for the Karman Project, narrated by Shelley Peregrine.
In the beginning, there was chaos. The immaterial, the unknown. A gaping void of darkness. And then, bang! Nothingness was turned inside out, into everything. Ever since, through years of evolution, the soul of ancient myths, the emergence of religion, philosophy, and science, humanity has always come back to the same question. Why do we exist? We look up in the sky, searching for something more. Dreaming. Humans, made of the same fabric. Chasing the most ambitious answers. Aiming for the stars, until we reach them together. We master our own limits. Limits of knowledge, of space, of time. We continue to explore, failing along the way, and growing as one. It's not in our nature to go back, nor to stand still. Once nothingness was turned into everything. Now the question is, what's next?
In our conversation with Xuelieng Bai, mention was made of Starlink. Well, SpaceX is launching thousands of communication satellites into low Earth orbit. The aim is to connect the people of the Earth. Well, this feature, The Beauty of Satellite Communication, features Jonathan Hofeller, the Vice President of Starlink Commercial Sales at SpaceX, and there's also others in this feature.
Once I got told that if you kick a ball strong enough, it will eventually keep orbiting around the planet. I close my eyes and imagine thousands of them moving around me. And I get lost.
it feels like when you're watching those satellites fly across the sky, and even when they're in orbit, it's in my mind, it's this peaceful dance, right?
There's a moment of pure absence when you close your eyes, right before you start seeing something through your eyelids. At the beginning, you feel lonely. I start thinking that I'm a drop of blood in the ocean, wandering, or that the earth is burning and I see it through a window. It doesn't feel right. I imagine being naked. I often dream about floating in space, thinking about what people can see from up there. The story says that there are thousands of dots harmoniously moving around the blue planet. I imagine them being able to receive something from us, reflecting it back to others. And I feel safe, kind of. That way I could talk to everyone without really needing a specific language. My language would consist of more than just words. Light bulb or a mirror. Everything could be reachable. Connect with the movement of others. It would be just like a dance.
People have been held back and somewhat prevented from being able to prosper and educate and just communicate. And we've seen this in a number of cases, some of the schools that we've connected, some of the indigenous tribes that we've connected, just an immense number of applications that require connectivity across the globe. You know, there's community centers, children's centers, women's shelters. There's just a number of applications that it's been very heartwarming to see that effect on people.
Australian Chris Boshuizen is a space industry entrepreneur. He answers the question, can we all access space with innovative ideas?
All of us have in our pocket more space capability than the USSR had when they launched Sputnik. And you can do that. In fact, if you ask your mom to mortgage the house, you can run your own space program as big as the USSR in 1957. And I love that little fact because it blows people's minds that they're literally walking around with an entire, space agency's worth of technology in their pocket. I think it was that moment where the goal was like, oh, well, I didn't know I could do that. And I think that's the key thing for me is a lot of people don't know actually how accessible space is these days, and they're actually allowed to do it. It's not up to governments anymore. You can do it if you want. Putting a phone in space is a really great place to start.
And that was Chris Boshuizen, co-founder of Planet and a partner at DVC. He now works in San Francisco. Now on to Feng Yan, the co-founder and chief executive officer of Spacity.
When I started to got into the space industry, I always believed that for the man, going to space is a very normal thing. So many years ago, the fish went to the land, and then we have animals, right? And some animal, they got dinosaur, they got They got wings, then we have birds. And then we got astronaut want to go to space, go to moon. And I believe in a couple of years, maybe 5 years, people can land on Mars. So I think human being get to space is like fish on the land, and the dinosaur get on the air, the same thing. But for the space traveling, that's a very long way to go. But right now, my dream, I want to make space industry affordable. I think the biggest problem for space industry before is so expensive, so freaking expensive. That's why I like Elon Musk. His rocket is not the best one, but his rocket is the cheapest one. His satellite is not the best one, but he can build thousands or tens of thousands satellites, and that's the cheapest one. And so many people can use that, can afford satellite, can afford the rocket. So that's my dream. That's the book I'm reading right now. Very classic one. After 20 years on the street, somebody meet a guy and ask him, what is your job? And this guy answered, I am a rocket scientist. And that guy said, oh, it's a very normal job. And that's all. Why I said that? Because 30 years ago, when you get on the street and you meet a guy, he's a software programmer. And you will say, oh my God, you are so brilliant. You are so clever. It's a very fascinating job. And after 30 years, right now, you find a guy, he's a software programmer. Okay, it's a very normal job. I want, after 20 years, you are a rocket scientist, you are a satellite engineer. If that happened, the space industry is very affordable. Everybody is using satellite, and everybody goes to the space. Like, for example, I took her to watch the movie called Interstellar. That's a perfect movie for father and a daughter to watch. And my daughter, after watch the movie, my daughter asked me, "Oh, wow, your job is so great. I'm so happy." And I took her to watch sun eclipse, and to watch the International Space Station get across the sky at night. It's very hard to watch, and she always gets so surprised and is so happy to do those stuff with me. Yeah, so I can convince her it's a very interesting thing to get a job in space. When I started Space-T, I don't want Space-T to be a Chinese company. I want Space-T to be an international company. I think the space industry is naturally an international business. It's global. It's interesting. So I just said that we want to get people from different industry to work together to find a better way. Also, I want to build an international team to cooperate together and to build a more international culture and to make the company better. Not only space, in many things, one country cannot solve that question, like COVID-19, like the pandemic. This kind of question cannot solve by one country. Every country should work together to deal the same problem. If we don't have trust, we cannot solve them. Like for space, the same. I just said we have to build trust and work together to face the bigger problems.
And that was Feng Yang, the founder and chief executive officer of Space-T. And he was reading Jules Verne's novel From the Earth to the Moon, and as you heard, wants to make rocket science a normal job. This is The Space Show.
88.3 Southern FM, local and live.
And this is The Space Show, and we're looking at the Karman Project. Now, when this next feature was recorded, Catherine Bennell was Capability Robotics Automation at the Australian Space Agency in Adelaide, South Australia. And her dream at that time was to be an astronaut.
For me, my dream has always been to explore outer space. As a child, I loved to look up at the stars and would get this wonderful feeling just for a moment where I felt in awe of how large the universe is and, how much remains to be discovered. Probably if I told my friends, I would have been totally teased. But for me, it was just such a passion. I wanted to stand on the surface of those new worlds, to look upon those new horizons with my own eyes. And being a young kid, the only visible kind of thing to be in that journey was an astronaut. And for me, it wasn't enough just to want to be an astronaut. I'd planned my whole life out in my head to be an astronaut. And, so I set out to find out how. And, according to astronaut Tim Peake, the British astronaut, he's written in his book that there's 3 main ways to become an astronaut. The first is to apply to your country's space program and work hard to be a good candidate. My country didn't have a space program. The second was to become a billionaire and fund your own way. Doesn't sound too bad, but money doesn't really drive little kids. And the third is become rich and then eventually die and then send your ashes into orbit. And that's not a great option either. So I went back to one, and I went overseas and pursued my dream to try and achieve that. But, becoming an astronaut isn't something that can be reached on a linear career path. And there might be just a couple of chances for anyone to apply or none at all. And so all you can do is look out for those opportunities and think about what motivates you. And for me, as I mentioned earlier, it was just that spirit of discovery. And there's a lot of ways to do that in the space industry. So I started out, as a space engineer on future missions, looking at what scientists want to know and designing missions to answer those questions. And then I moved on to a running mission called LISA Pathfinder, which is looking at gravity waves and potentially opening up a whole new spectrum to explore the universe. And then I moved overseas and looked at, hey, how do we preserve space by removing space debris from orbit, and looking into how can we go up and capture satellites. And that was really interesting technology. And then I had the opportunity to work on concepts for exploration, the Lunar Gateway and the ISS, and augmented reality systems for astronauts, and innovation, project management, and then Bartolomeo. So through that, I'm continuing to progress what I love, and I suppose that dream's still in the back of my mind. But what I have done is maximize my chances by working really hard, and I've really enjoyed, and I will continue to enjoy what I'm doing. I've lived across more than 6 countries now, and to achieve the most sought after qualifications and skills that keep me motivated, but also keep that dream alive. And whether I become that astronaut or not, who knows? I'll never regret, striving to do so. And I have and will remain committed to help explore outer space from Earth, and to try and further the vision for space exploration. I never thought I'd have the chance to help grow an entire country's space program, their space capability, and help to, or actually define their visions for where we want to be in the next 10 years. And it's an absolute pleasure to do it. I'm not sure what I'll do next. Hopefully, I'll just look to the next hill on the journey that along the path that motivates me. And for me, what I really like is making sense of complex systems and complex problems, whether that's a technology, a spacecraft, a roadmap to how a nation will build space capability, and doing that with a team. So for me, it's about discovering how to do something, and the motivation for discovering that how is the why, the question that we might answer through what we're creating. So yeah, if you're discovering a planet every day, you're in pure discovery. And if you're designing the telescope for how to look at that planet, you're creating something that can be used for discovery by many. So,
well, since Catherine Bennell from the Australian Space Agency recorded that, she applied to the European Space Agency to become an astronaut, and guess what? She came very nearly to achieving that. And then the Australian Space Agency said, well, you come so close, we may as well pay for you to go there. And she went and trained as an astronaut. And so she's now qualified to go into space as a bona fide Australian astronaut. We'll see what happens in the future to Catherine. Now, we're looking at the Karman Project, and Hannah Ashford is the Director of Community and Fellowship at the Karman Project. In response to the question, what inspires you most in regards to your work in the space sector, this is what she had to say.
I think that everyone, when it comes to space, will have these sort of formative moments in our lives that we remember. And, you know, whether it's sort of watching astronauts be launched into space, or a rover being landed on Mars, or, you know, in our case on the Karman Project, we hear very personal stories of these people. And, you know, it's one thing to see a YouTube video, a YouTube live stream of someone going off into space, and then it's another to actually have a relationship with that person, as, you know, many people within our community do. So I think we all have these formative experiences which sort of touch us. But I think with me, I'm really inspired by the everyday and by all of the sort of behind the scenes things that, quite frankly, I was not aware of at all until I started working in the space sector. And I think having an understanding of all of these small behind the scenes things that are happening, and then understanding the profound impact that they're having on Earth, that is more inspiring to me than any one story. One thing that Tomo was saying, which sort of really stuck with me, and I think comes back to this wider community of space, was, you know, space is really basically ready to kill you. You know, everything is against you in space. And when you go out there, all of the elements are against you. And one way to think about it is that when you're an astronaut in space, there is just a piece of aluminium between you and your death. But the way that Toma thinks about it, which is something that really resonated with me, is that it's not just a piece of aluminium between you and your death. It's that plus an army of thousands of people who have worked to protect you and to get you to this point. And I really think that sort of captures this essence of the space community, that, you know, we will see that one element of a rocket launch, or of a landing, or of, you know, the capsule docking on the ISS. But for that moment, the years and the lives and the dedication and the study and, you know, the amount of human resources and effort and dreams that have gone into that is just incredible to me. And I think that it really captures that that sort of 360-degree angle, that space, you know, it just broadens our horizons. And I really loved that anecdote from Toma, because I think it just it speaks to community at its core. And I think that's something that inspires me when I think about that. I think when it comes sort of conceptually to dreaming, my instinct is to think big. So when people say, okay, what do you dream about, or what do you consider to be dreaming? I really think about, okay, those who sort of push the boundaries, explore limits beyond their normal realms, and really, again, push us as a species to move our experiences forward. And I think this is certainly true. And I am grateful for all of those bold characters and entrepreneurs and, you know, the people who can really turn the, you know, I wonder into the I think, into the I know. And I really like that journey that dreaming can sort of help to facilitate. But I think what is also interesting to me, and I think it's something as well that I have noticed as a person who has had the privilege, certainly, of living on different sides of the world and operating within different communities, is that I think that we as a generation, and And when I say generation, I sort of speak generally about the younger generation. So say as those who will be the custodians of planet Earth for the next 50 plus years. I think that our collective shared dreams are actually quite modest in their form. And I think that that is something that has really struck me and resonated with me as I have sort of moved around the globe and come into contact with different people in different communities. And I believe that what we dream of at a very fundamental collective level is just really equality in various forms. So in forms of gender representation, or in forms of race, religious expression, accessibility of different opportunities of education, of food, of healthcare. And I really believe that these are actually quite humble and modest dreams. And I mean, but this is what we as a generation in various communities in various parts of the world that we sort of speak of and wish for. And I think while these dreams of our generation are sort of modest in their form, you know, I'm under no illusion that they are easily achievable. And I think that, you know, achieving equality in all of these realms requires courageous conversation. It requires diplomacy. It requires a lot of policy reform, and indeed it requires a lot of systemic change. So I really think that my instinct when it comes to dreaming is I immediately think big. But then when I really think about our collective dream as, say, a generation, I actually think that it's sort of quite humble and quite modest. And that's something that, in one sense, the optimist in me loves, because then I think it's quite achievable. And that also drives me in terms of understanding my place to contribute to that dreams.
And that was Hannah Ashford from the Karman Project. And now to Xuelieng Bai. She's visionary, co-founder and chair of the Karman Project, and she's also vice president of the Orion mission. And she explains why she thinks it is important to bring people to the moon in the context of settlement of Mars.
We are currently expanding the boundaries of our life habitats. So we are exploring the universe, and we want to settle in the moon first and then in Mars. And this is, I think, just part of who we are as humans. We've already pushed the boundaries of explorations, and it's just like music or like art or like spirituality or whatever. It's just part as who we are as humans. So I'm convinced we'll go to Mars and probably farther in the coming future. And so in this journey, Moon is the first step of that journey. It's a step where you can learn a lot, because to settle on Mars, there are many questions mark. How are you going to produce electricity, for example? How are you going to ensure communication, for example, etc., etc. There is also the question of sustainability, and because if you go there, it takes you 6 months to go there, so you better have thought through a plan which is a minimum sustainable, because of course you'll not be able to carry with you everything you need, and then if you want to go back, it will take another minimum 6 months, right? So it's much better to have a playground which is a few days far from the Earth, and where you can already kind of mimic what life could be on Mars, and where you can solve very important challenges, as I was saying, like energy, for example, in a place which is not too far from the Earth. So, and then something which is especially interesting in the Moon is that you have tons of water ice, so water, and with water, of course, you can produce propellant, because the spacecraft they use liquid hydrogen and liquid oxygen, or they use liquid methane. So the Moon is a great refueling station, if I may say so, to explore the universe further. The Moon is really here the first step to learn how to live in a sustainable manner before we go to Mars.
That was Xuelieng Bai. William Gerstenmaier is Vice President of Mission Assurance at SpaceX, and he comments on what he thought when he saw Elon Musk launch a Tesla Roadster into space. No, Okay, that's what we're going to have on next week. That's a preview of next week's The Space Show. And this has been The Space Show with Andrew and Richard.